Welcome everyone to today's webinar and Happy New Year. It's 2025. We have a really great group of people on this webinar, and I'm excited about it. There's a lot of content that I have uh, to highlight today, and I'm going to get right into it. I'm actually using two different computers, so you see on Zoom the wrong square is talking. I have some screen sharing from a different computer because I want to do a different demo. But all of you should see the title slide, "What's New in .NET," and you should be hearing me just fine. From a Q&A perspective, the question and answer window on Zoom is enabled, and so you can put in questions there, and I'll weave them in during this session. And of course, after I finish everything that I have to share, I'd love to just answer free form questions if you have them. And Chloe is going to be helping me on chat with some links to various things. And if you have any logistical issues, then you can um, go ahead and chat with her while I'm going through. So let's dive in. We are talking about what's new in .NET 9. .NET 9 is only about 2 months old, and it's the latest version. It's a what they call a short-term release, but that's because there's now a new .NET version every year. And the good part about that is that there's a new .NET version every year, and every other year is a commitment to long-term support, which is not the typical 10 years that long-term support used to be. So it's really less of an issue anyway, and it kind of causes a little bit of confusion between long-term and short-term because they're both pretty darn short, but because they come out every year, after .NET 5, really after .NET 6, the compatibility jump between each of them is been very small. So it's a very small lift to go from .NET 6 to 7 to 8 to 9. And typically you can just change the number in your existing Visual Studio solution if you're on .NET 6 or above, and it just works. So that's good. Um, so let's kind of dive in here. Um, Most of you have been coming to Clear Measure training sessions for some time. See a lot of familiar names in the list here. But ClearMeasure is a full service software architecture and engineering firm that serves companies building mission critical software systems using .NET and Azure and other Microsoft technologies. And we focus on developing custom software and helping our clients do the same and rescuing failing projects. We also do advisory services and inspections. Our goal is to empower software delivery, and that's our passion. We focus on the Microsoft platform and everything around the Microsoft platform and everything going forward. Every new technology that comes around for the last 10 years, DevOps has been a big mover and shaker. 15 years of just getting to the point where everybody can create servers and computing and cloud resources from scratch, from scripts, and then configure them automatically and deploy automatically and test automatically. So we drastically drive down uh, bug rates so that our software engineering teams can actually spend all of their time doing software engineering instead of just fighting fires. So, um, just a couple of months ago, my latest book came out, The Five Pillars: Leadership for Effective Custom Software. This does not actually have any lines of code in it. My older book has plenty of code in it, but this one is for more philosophy evergreen, um, how to actually run software projects, the five things that you need to focus on for any software team. So I'd love to get now it's available on Amazon, hardcover, softcover, Kindle, even audiobook through audible.com. And we have some discount codes for Audible, and I'd love to give you a free electronic copy of the Five Pillars book. If you'd like to, Chloe can help you out in the chat. My older book is .NET DevOps for Azure, and while the code tends to age, when it's like 5, 6 year old code, the code looks a little bit different, 6 years later, but the concepts are the same. And so if you're still working on automated DevOps, then I'd love to get that book in your hand as well, and just use the chat to request a free electronic copy of that book. And then some opportunities that we have every month are some interactive forums that I facilitate. One for software architects who are the lead of software engineering teams, but also, your hands are still in the code. And then the software leadership forum, which are for executive managers who oversee software teams, but whose hands are not in the code. Topics are a little bit different, but we have those two forums. And so if you're on a software team and you want maybe your VP of engineering to be the absolute best executive leader, well, send them to the software leadership forum. We'd love to have them. Clearmanager.com/forums. All right, now into .NET 9. If you weren't aware, I would encourage you to go to YouTube and go to the .NET channel on YouTube, DOTNET. That is the .NET channel, and every single session from .NET Conf in early November is cut up and available there. And the .NET Conf keynote is the YouTube link on the screen, but just search for .NET Conf 2024 keynote in the .NET channel on YouTube, and it'll pull up kind of the overview. But in the era of .NET 9, this is what .NET looks like. We can build cloud applications, web applications, desktop, mobile, gaming, IoT, and AI. And for the Microsoft Ignite conference, which was in late November, and I expect the Build conference, which is coming up in May, I expect a big focus to be on AI development because it's just a huge it is a huge new technology area, tons and tons of investment. And so as software engineers, so many of us are our entire career we have to be generalists, and here's a new set of tools that need to be in our tool belt, and that's the AI tools. And so there are certain people that choose to specialize, and that's fine. But a specialty career is very different from a software engineering career. Software engineers, in general, are generalists, and when a new tool comes out, great, we learn it, put it in our tool belt, we use it when it's appropriate and how it's appropriate, and we keep on building great automated solutions with software. All right. Okay. So I'm going to highlight. Let me say this. There are so many announcements and so many things and new features that are in all of the recorded content from .NET Conf and the announcements of .NET 9 that it wouldn't be appropriate for me to regurgitate everything. I have chosen to highlight some of the things which I think are the most interesting and the most impactful, and that is how I chose to jam pack this session here. So I'm not going to touch on everything. I can't touch on everything. I'm highlighting the ones that I think are the most interesting that you should really pay attention to. But then, of course, if your entire world is desktop with WPF and WinForms apps and all that, then you're going to have that focus, and you're not going to care about any of the other things. So your world, you have to choose. But I've made a choice. So here we go. All right. Since last year, since .NET 8, there's been quite a few changes, and one of the big ones is the .NET Aspire official launch that happened. There was the first version and whatnot. Also, .NET MAUI for VS Code, I'm going to highlight that. And smart components, not only in Blazor, but also from third-party vendors, are UI components that have integration with large language models or the current crop of AI tools built in to do kind of automated processing of whatever the input is. That's kind of interesting. And the new version of Ubuntu in Windows Subsystem for Linux 2, WSL2. And so that's really interesting since last year. And then the .NET Community Toolkits, those have come out, and GitHub Copilot. I want to highlight that. I don't actually have a slide for GitHub Copilot, but there is now a free tier for GitHub Copilot. So if you're at an employer who hasn't wanted to pay for GitHub Copilot and you haven't been able to do it yourself, there is now a community edition. Just like there's a community edition of Visual Studio 2022, there is now a community edition for GitHub Copilot. So anybody is able to learn and see what GitHub Copilot could do for you. And now it's limited to a certain number of requests and whatnot. It's not meant for if you're using it for actual full-time development and commercial purposes, you're expected to buy a license. But it did not have any kind of free tier before, and now it does. So that's cool. All right. Okay. Um, there's often questions that I get about .NET because it's not really clear. You hear all kinds of talk about different technologies, and we don't really know about how particular programming languages are and how widespread and whatnot. .NET is growing very, very rapidly, and the ratings for it is very, very good. The performance for .NET applications is top tier in the top five, and it's only beat out now by small research programming languages that nobody actually uses to build applications, and I don't even know the names of. So it's the fastest full software development platform on the planet now. It is growing at a crazy rate, and people love it. It's the number one most admired developer framework, according to the Stack Overflow developer survey. So, um, for any of you who maybe are at a company that has multiple technologies and you're thinking, this next application, should I use .NET? Should I use something else? Just know it is a great time to be building with .NET and using all the technologies surrounding the .NET ecosystem. Okay, a little bit of performance highlights. So from .NET 6 to .NET 8, and then extending to .NET 9, but 8 was a huge push. So the numbers for the same application, we are down 35% CPU usage, so better performance. We're down 30% memory consumption, and some of the other highlights. Windows Copilot was rewritten in C Sharp, and is using .NET and has been rewritten in .NET 8 just last year. And the code base went down, the performance went up 3 times, and it's got really great reliability. And that's a great success story. Microsoft internally at Microsoft, for a long time, well, in the last 10 years, it's been significantly different. But there was a time earlier in my career, with the first 10 years of .NET came out, I think when .NET came out, I was in the third or fourth year of my career. That was back in 2001, 2002, when it really came out. 2002 was the first Visual Studio .NET version. And Microsoft was still using all C++ for all of his stuff. And of course, the question was asking, it's like, okay, Microsoft, you have tons of C++ developers, but you're wanting the whole industry to use C Sharp, but you yourself use C++ for everything internally. Why don't you use C Sharp? Whereas this past decade is very, very different. All of the, not all of it, but the massive amounts of new development inside Microsoft has all been C Sharp. And so Microsoft runs on C Sharp and .NET. And so that's a big success story to help you think about, how serious the .NET ecosystem has gotten over the last now 24 years. All right. So for .NET 9 specifically, um, the highlights are in 4 different categories: productivity, security, intelligence, and performance. And I'm going to highlight a few of these. You can kind of read the other categories on the screen. Um, adaptive garbage collection, that's something under the covers that we probably never think about. And unless you've read one of the um, Jeffrey Richter CLR by C Sharp or Applied .NET Framework books and have actually learned for yourself how the .NET garbage collector works, which by the way, if you have no idea how the garbage collector works, it's a good idea just to know. Maybe search for a video that just explains it at the high level. But adaptive garbage collection has changed rather than the Gen 0, 1, and 2, and then the large object heap. So that has increased performance for all ASP.NET applications, optimized static web assets. That's just automatic now. And then, of course, .NET Aspire, I'm going to go into that in more detail. I'm going to highlight those. Okay. So let's talk about Aspire. If you've kind of been following some of the announcements, .NET Aspire has been all over the place. It's kind of been two themes, two big themes in the .NET developer world. One is .NET Aspire, and the other is all the co-pilots and AI and AI and Aspire and AI and Aspire and AI and AI and Aspire. Like a broken record, they have kind of dominated all the talking points. Well, .NET Aspire is a big deal, and there are the last mile. Yes, we're still waiting on the last mile of automatically deploying and creating environments and then doing the deployments so we don't have to do all of the DevOps automation ourselves. Yes, we're still waiting on the last mile for that. But the first step, which is the developer's inner loop, which is you clone a Git repository, you have the Visual Studio solution open on your computer, you hit Control F5, and you run the entire application, multi-project startup, everything online, everything connected, and it just works on a developer's workstation. That they've really nailed it. And the few little tweaks that were necessary to integrate with Docker Desktop and the containers and more integration, making more integrations available in .NET 9, .NET Aspire has really nailed the local developer experience. Okay. Now, from day one, when they announced .NET Aspire was, this big vision, and step two and step three of the vision are still being worked on. Step two being integrations for everything you might want. Redis cache, RabbitMQ, Azure Service Bus, just all SQL Server, Progress SQL, PostgreSQL, everything that you might want to use. The body of integrations is growing, but the integrations model is there. And then the step three is integrating with the Azure Developer Console and automatically generating things that you might use Terraform or Bicep or ARM templates to automatically create resources or to automatically spin up VMs, whatever your environment is. That's step three, to automatically create environments, automatically deploy a new version of the code to those environments. That is still being worked on. But I want to pull back to step number one, and that is the developer experience. And I have a demo in just a bit. Okay. I'm just going to show you this. I'm not going to talk through all these, but I want to highlight at the top of the screen one of the videos that I would encourage you to search for on the .NET YouTube channel, and that is literally, quote, "What's new in .NET Aspire?" Simple as that. There's a full presentation that goes into a lot of detail about all the little bits and bobs. Okay, so let me highlight .NET Aspire integrations. There's already a lot of them there, and I'm going to highlight Aaron Powell and David Pine, and they also search the .NET YouTube channel for their presentation, .NET Aspire integrations, and they go into specific detail about a lot of these and how to create your own integrations, because there's going to be things that your .NET application needs that are not going to be supported directly by Microsoft, or just, there's special cases. And there is now a protocol and an abstraction model so that you can create the shim over the top of whatever dependency that you have, so that you have declarative ability to just have an Aspire app and have it automatically spin up whatever that dependency is. And so I know Aaron Powell and his team are really working on getting the most common ones accounted for, either directly supported by Microsoft or working with those vendors and helping them uh, spin up a .NET Aspire compatible integration so that it's available to the whole developer community. And in on GitHub, github.com/community toolkit/aspire is a growing list of integrations that are already available. And you can take the names of all of these and just search for Community Toolkit Aspire, and then you can see all of these as NuGet packages on NuGet.org. All right. So actually, well, I'm going to do a demo in just a second. I want to highlight the AI ecosystem from a .NET developer's perspective. Um, in Azure, you've got semantic kernel, you've got Azure OpenAI, you've got AI search, you've got OpenAI library, and then you've got a lot of components from Syncfusion, DevExpress, Progress, Telerik, and such. And you've got Llama, large language models, you've got GitHub models. So there's a lot going on. And .NET Aspire, well, every software engineer needs to be able to work with these AI models. And of course, we're finding that, you know what, guess what? You need a lot more hard drive space locally, because even to play around with some of these models, you're downloading 7 GB. And so if you're going to download and work with, a number of them to test out, which ones are better at certain tasks than others in certain queries, then you're going to use up and churn a lot more hard drive space. And that's just a reality. And we're also learning what kind of hardware that need to be in the general purpose software engineering workstation computer, whether it's a laptop or a desktop. And we're realizing that, it used to be, when it was for people who largely maybe just did web development, you could get away with a lower horsepower laptop computer and kind of be okay. Whereas now, in order to put modern AI into the software engineer tool belt, we need a different type of computer. We need a different type of chip. And the Copilot era of CPUs had a standard of a neural processing unit NPU of 40 TOPS. TOPS. That's the measure of number of AI transactions, and 40. So 40 TOPS. Well, the normal i7, i9, latest generation, I think they were able to do 5 TOPS maybe. So 40 was a big jump. But the NVIDIA GPUs, they can do 500, 800, and the new 50 series, the lowest end of the 50 series is at 1,000 TOPS. And the highest end, I think I saw the announcement from the Consumer Electronics Show in Vegas this week. The highest end of the new 50 series is 3,500 TOPS. So these Copilot PCs will say, oh, you have to be able to use at least 40 TOPS. Well, the hardware, it's way faster than that. So if you're just using a CPU to use a large language model and you say, oh man, it's really, really slow. Well, yeah, because we need some different hardware, and it's going to take a while before these different chips just become ubiquitous. So I will say that if you're using the large language models locally, you want an NVIDIA chip. They're basically so far ahead of the market. They're so far ahead of Snapdragon, Qualcomm, anybody else. You want an NVIDIA. Basically, the easiest way to do it is to tack on an NVIDIA GPU to your system and configure configure Olama to use the GPU and make sure it's not using the Intel GPU or just the CPU. So I just want to touch on that. So now we're going to go to a demo. And this code is available right now. And by the way, if you don't have an NVIDIA GPU, this will still work. It'll just be slower on your machine. Just clone this repository and open it up and just hit Control F5 and run it. And if you have Visual Studio 2022 with .NET 9, then it should just work. Well, you do have to have WSL 2, Windows Subsystem for Linux 2 installed on your computer, and you have to have a functioning Docker desktop that is running and just running in your system tray. But if you have that, then go to github.com/Jeffrey Palermo/aspire-olama and it should just work. So let me just pop out of here. Let me go into Visual Studio. Actually, I'm gonna stop this from running because I want to start it from scratch for you. And I'm going to go to this. I'm going to go from scratch. Let me just close out. Okay, here we go. So this is the Visual Studio solution. And we have the Aspire, the generic Aspire solution with some things added in. One thing that's added in, and by the way, we are right here in the program file. One thing that's added in are these lines of code right here. Olama, builder.add-olama with data volume, with open web UI, which is kind of optional, with container runtime args to use all the GPUs, okay? And then we're just using the model Phi-3. Phi-3 is not one of the best ones, but it's one of the smaller ones, and it's out there, and it just works. And it can do, basic things. So we have that. Now, the web front end, this was in the default Aspire template, but what we've added is we've added a reference to Phi-3 and a wait for Phi-3, because what this does, there's no Visual Studio solution, or there's no project for the Phi-3 Olama model. This is going to be one of the integrations. This is going to be one of the other Docker containers that spins up and needs to be running locally before the web front end, as you see on line 15, before the web front end, which is just basically a Blazor web application, can be ready to go. And in the web application, the only thing that was changed from the default template was some code in home. And some code in home, all I did was to add the basic Olama client. It's just the getting started code. Basic Olama client and a text box that just funnels it in there. Okay, let me just hit Control F5 just so you can see it spinning up. So just like any .NET application, it's going to spin up, and then the Aspire dashboard comes up. I'm going to push this over here so you can see. And so now the dashboard is up. Now, it takes a little bit for this Olama container from going to unhealthy to healthy, the open web UI. Now, we're not actually going to use the open web UI, but it's available so you can kind of test it out. But I will say the first time you do it, Pi3 is going to take a long time before the label of unhealthy goes away. And that is because it's starting up, and one of the things necessary to start up is it has to have the model that is declared, the model Phi3. And it's going to automatically be downloading this big old file, and it's going to be downloading. So until it's actually downloaded the model specified, then it's not going to have a green light and run. Okay. So let's spin up the web front end. And now here we go. And we're going to be using, let me just say, and it takes, on the first request, it takes a little bit to spin up. So I'm going to ask, howdy. All right. And it takes, I don't know, 5-10 seconds for it to respond back, because we literally just, and everything is local. Every single thing is local. we're not going out to Azure. So this is .NET Aspire. It's spun up multiple containers and now it's spun up. I just said howdy. So let's just give it a task to do. Let's see. What is a synonym for awesome? All right. And there we go. And I'm gonna make this larger, make the text larger, and I'm gonna hit ask. All right, so what is a synonym for awesome? And here's the response. Okay. Now I can give it more. I can say, hey, only, limit your answer to 10 characters. So many of the prompt techniques that we've learned with other large language models are valid here. And you can add attributes in the prompt. But just this here, what we've done is with .NET Aspire, and I'll go over to, I just want to highlight um, the dashboard. Let me move this over here and pull this up here. What I want to highlight is the .NET Aspire dashboard shows you the different processes that are running locally. So Control F5, I have multi-project launching and not just multi-project startup like we've had in Visual Studio for a long time, even though it's more clunky. But now I have other dependencies, these Aspire integrations that are also spun up automatically. So the default project template also comes with a Redis cache. So even though this sample doesn't use Redis, well, here we are, cache. The cache is running. No big deal. Great. Even this, the helper of Olama Open Web UI, now it's running and it's healthy, but we don't care about it. We're not going to use it. And then the default template has API service and it's running and it's all good. All we used for this demo was the web front end and the Phi3 container, and the web front end was configured automatically with an environment variable that gave it the address for how to actually contact the Docker container that was running the Phi3 model. So I want to stress again that that just sending something here. Let's see. Synonym. Somebody in the chat, give me another word. Let's find a synonym for another word. Throw it in the chat. And we'll just run it through a couple more things. Just to prove that it's all right. Well, I already did awesome. Give me another word. All right, ridiculous. Ridiculous. All right, absurd. There we go. Fantastic. All right, let's do that one though. So just kind of proves, and this is just a bounded fantastic. All right, awe-inspired. So this model is running locally on my computer, and it's not going out there. So we might be looking at OpenAI on Azure or Azure AI services and semantic kernel and thinking, okay, that's great. It can host, all these different models, but it's expensive. And we can do a lot of interesting things with these large language models that aren't exactly like super large. You might call them small language models for the ones that are, less than 10 gigabytes. But we could have applications that are running anywhere, and this is just containers. If you can run it inside of a Docker container, well, now we can kind of run it anywhere. We can host these container images running in app service. We can do it in Azure Container Apps. You can do it on a VM. I mean, and locally I'm using WSL2. So and and forget chatbots. Everybody's trying to do a chatbot, but you don't need to use a chat. Chatbot is not like the main way for using these very manageable large language models or small language, this AI technology. Um, if I have any kind of user generated content, if I have comments, or feedback or any kind of things from my customers, I might want just a backend process that rips through those comments and says, you know what, on a scale of on a scale of 0 to 10, with 10 being very favorable and 0 being customer is pissed off, where would you rate how this user is feeling on a scale of 0 to 10? And rip through just this freeform content that we may have gathered over years and years and years of customer comments. With maybe we didn't have a rating scale, or maybe we want customer questions coming in, and we just want to do intent extraction or things like that. That's perfect for these models. And so there's all these little tasks that we can do in a very, very easy way with this new AI technology. And Aspire makes it very, very easy. Olama is already one of the .NET integration, the Aspire integrations that are available. And literally, it's just a NuGet package, configure. And let me just show you in Visual Studio again how little code it was. Now, the screen that actually does it, um, the screen that actually does it, let's see, here's the text input. We're binding the value prompt. This is just a Blazor screen. Boom. So there's prompt. And now when I press the button, yeah, get prompt. So when I press the button, there we go. Input type submit. On submit, we're pressing get prompt. So this method runs when we hit that. Let me just close this up so you can see the whole thing. And literally, we are just making sure that client's not null. We got something in the prompt, and we are saying client complete streaming async, passing it in. And so now we have a stream. And so we just await for each on the stream, and every new word that comes through, we're going to, append to response, which again, in our UI, we have response just being inside of a paragraph tag. So it grows as that for each loop kind of goes. And then the only other code that we had to put, well, let me just show you inside dependencies, we've got NuGet package, not projects, NuGet packages, and we have Aspire, let's see, Redis, and there we go. Community toolkit .aspire.hosting.llama, Olama. And we have lines 8 through 11, no, 8 through 13 that were new from the project template. And then we have lines of code 20 and 21 that were new. That's the only code necessary to just get one of the open source AI models to run locally on whatever environment I want. And so um, there it is. There it is. Okay, let's get back to presentation and let's keep going. All right. So next one. And I wanted to give credit to Stephen Hook. He has a great presentation on Azure integration with health checks. That's also available on the .NET YouTube channel. And I wanted to highlight health checks, not because it's a sexy feature, but because it's something that changes some aspect of the way that every .NET application should be written when it comes to monitoring these in a downstream environment, in production and pre-production. And it's the concept of a health check. Now, the health check framework, the iHealth check interface, that's not new with .NET 9, but the integration with it, making it an absolute first-class citizen and baking it in everywhere, there's been a lot of progress in .NET 9. I would say as with .NET 9, you want to bake it in everywhere because all of the infrastructure in Azure is now built to work with it. And so I wanted to highlight a few concepts. So and I don't have code or a demo because this isn't very complicated. You should already be using the iHealth check interface and the health check packages. But effectively, you just create some number of classes in your code that implement the iHealth check interface that's provided by the NuGet packages, and you write arbitrary code that does something, and you return back one of three statuses. One is healthy, one is degraded, and one is unhealthy. Those are your three choices. And let's just say you have code that needs to write to a database. Obviously, if you can't get to that database, you are unhealthy. There's no ifs, ands, or buts, but your code can't do anything. It's not degraded, it's unhealthy. Now, maybe if you send text messages via Twilio and you can't get to Twilio and you have to queue up some text messages, well, maybe your application is not unhealthy. Maybe it's just degraded because you're not immediately able to send text messages and you're saving up these text messages in a queue that are going to be sent once Twilio comes back online. That would be an example of degraded. And so the code for the database scenario, for the code, you would write, if you're using Entity Framework, you would basically just get your data context for Entity Framework and probably call the connect or the check connection method and just see if you could connect. And that would verify that that the connection string is right, that the firewalls between the application and the database are online, and you can actually reach it. If you want to go further, well, then maybe you just run a very, very small query against a known table or something. Either way, you write just a little bit of code that is designed to fail if we can't get to the database. And if we can't get to the database, then we return unhealthy. If we can get to the database, then we return healthy. And now Azure knows an app service and Azure Container Apps, now they are built to integrate with this so that if you have an app service plan and you've got more than one instance scaled there, then and if one of the instances is unhealthy, well, now app service is smart enough to say, oh, it's unhealthy. I need to stop sending traffic to this unhealthy node, and I need to spin down this unhealthy node and recreate it and basically spin up a new node and put in a new second node into the load balancer in your app service plan. And so it's the same thing with Azure Container Apps. I'm going to stop sending traffic to the unhealthy node um, and do that. Also, for the load balance scenario, after 10 failed checks, the app is just totally removed from the load balancer. Um, and after an hour of failed checks, the app is going to be completely reprovisioned to a new instance and not just recycling and restarting the app, but totally reprovisioned. So Azure is getting more intelligence, and it's built on you putting in these health check endpoints into every running process of your .NET app to help it out. And then you get this automatic restart, and reprovisioning resilience inside Azure. So that's something I wanted to highlight because that's pretty phenomenal. It's something that for years and years and years, software teams have had to do in a more manual fashion, and yet another very, very important thing that's becoming more automatic. Okay. Next item I want to highlight is uh, the .NET MAUI extension for VS Code. So um, there's a there's a recording, a session, quote, what's new in .NET MAUI, and just search for that in the .NET YouTube channel. And that's a pretty deep session. But the MAUI team is really trying to make it more accessible to build mobile apps with MAUI. Um, Now it's still got a ways to go. Um, you're still kind of a second class citizen if you're using Windows to build MAUI apps. Yes, it kind of works, but when you see all the people and even the people on the Maui team at Microsoft all using Mac computers, and this extension for VS Code instead of just highlighting the Visual Studio features, I would say that if you're doing these, you're going to have a better experience using a Mac than using Windows. Now, I hope that changes because Visual Studio, the full Visual Studio 2022 is the flagship, and and that's not going to change anytime soon. And so the reality with .NET MAUI apps is you probably want to be using a Mac, and VS Code with the MAUI extension is a new way to use it because VS Code for Mac was discontinued, and JetBrains Writer is the official recommendation from Microsoft for doing .NET on Mac, except for VS Code. And so they're building up VS Code. And so if you're doing .NET MAUI apps, then you might want to try the VS Code extension. And it spins up the emulator right there on the side. And that was a big announcement. All right. So regular, I would say regular ASP.NET Core in .NET 9. Yeah, Blazor, I've said it before. If you attended my last year's What's New in .NET 8, Blazor is now for web applications. Blazor is the new normal web application. Um, it allows you to do stateful web applications that make use of the CPU and the memory in the client's browser. And there's been a lot of performance enhancements and control enhancements. There's now some more hybrid templates. There's a grid built in. There's 25% faster Blazor startup. And there's a better authentication enhancement loop. So if you still haven't done anything significant with Blazor, then I would recommend that you do it. When it comes to the hybrid templates, the premise there is for applications that have internal users or for a very predictable load, you can have really, really fast startup time by using the server-side model for first render, and then it'll transition to the WebAssembly model. Now, if you are going for the public internet um, where you have unpredictable scaling characteristics, then you're just going to want to skip the hybrid model and just go straight to WebAssembly. If you think about it architecturally, Blazor WebAssembly architecturally is the same as React and Angular and Vue. And that is, if someone's never gone to your website before, um, you might have some of these, animated gray bars in certain sections of your page, and then it takes a couple of seconds before those sections of the page become populated. And why is that? Because behind the scenes, the browser is downloading the code. And for the JavaScript frameworks, it's we're waiting to download the JS files that have the code that needs to run to populate that section of the screen. Blazor WebAssembly, it's the same thing. We can paint the shell of the page, and we can have some statically rendered sections. But in order to fill in a section of the page that's a Blazor WebAssembly, guess what? We have to download the code. Well, the code happens to be a WebAssembly file that's a .NET assembly instead of a JavaScript file, but architecturally it's the same thing. We have to wait to download the code, and then we have to run the code locally, and it fills in that section of the page. So architecturally, it's the exact same concept. And for most applications where you want clients a rich client-side application, then that's fine. You just show something moving in that section of the page. And we um, for React and Vue, we just wait for the JavaScript to download. For Blazor WebAssembly, we just wait for the code to download. But that only happens once. Forevermore, until we deploy a new version, it's already downloaded and it's super snappy and rich, and it works great. So that would be my guidance for Blazor WebAssembly. For internal applications or scenarios where you basically know the users who are going to be using it, it's not a high scale application, it's very predictable, and you're not scaling up, then yeah, Blazor hybrid works fine. Um, However, I tend to favor just going straight to WebAssembly, because then you have one network model to work from, where you know that all the requests are going to go from the client to some sort of web service, and then it's going to be processed into the database or wherever, as opposed to um, the the hybrid model with the server side code running straight from the server to the database and then streaming over a WebSocket to the client. Because then you still are managing two different network models. Or I think it's just simpler to have the one. So I'm in favor of just going straight to WebAssembly, because that's a much more powerful and flexible model, in my opinion. All right. Okay. I want to talk about IoT but a really, really interesting announcement for IoT and AI. And the concept is called Edge AI, which is running AI models in a system on a chip computer, just wherever it is, wherever it has to be, in a factory, in a business, on a, tiny little chip, um, on something smaller than a deck of cards, essentially. That's what Edge AI is it's a small computer somewhere that can run some type of AI model. And if you have a bigger, more powerful computer, you can run one of the larger ones. But really, on the edge in the IoT space, you don't care about running a large language model. You don't need a large language model that has all kinds of training that can do all kinds of tasks. You need one of the smaller ones that can do specialized tasks. Maybe you need it to understand the English language. Maybe you needed to understand some numbers or something and do more specialized tasks. So they're going to be smaller in nature. And Wilderness Labs has announced their Meadow F7 for Edge AI. And one of the interesting things is not just the power that it has to run .NET apps. You saw what I with the .NET app and running Olama. Um, so the Meadow F7 has already run .NET applications for many many years, and so anything you can do in .NET, you can do on these little guys, but it's the ecosystem that they're working on. So their sensors from useful sensors, and these sensors are coming with built-in purpose-built chips that have and I don't actually understand the internal guts, the internal architecture, but seemingly some type of small, like tiny micro model that knows how to do one thing. And so this camera that shown on the screen, it is a teeny tiny little camera, and it it uses the Modbus, I believe it's Modbus. Um, Either way, the F7, the Meadow F7 can connect to it, and this camera just doesn't show an image. This camera can give a signal that it has detected a person. It is a specialized camera that is a person detector. Now, I could have a webcam and I could take pictures I could take pictures every 1 second, and I could process the picture through an AI model, and I could ask it, are there any people in this photo? And if I had a AI model that knew how to process images and detect what was in the image and detect there's a person, I could definitely implement it that way. But this sensor itself and the printed circuit board behind it doesn't just give you the picture, it gives you the notification that there is a person. And so more and more of these sensors and IoT uh, integrations are coming with some of these AI powered tasks already built in, so that there's less code that we have to do, less general purpose code that we have to do on the edge and in the IoT space with our .NET code in order to support common scenarios. And so if you're doing a security application or some type of monitor, and you didn't want motion detection because maybe there's trees, maybe there's leaves, maybe there's animals. You specifically wanted to record that, hey, there is now a person in this space. Well, this is a really cool development, and they're coming out with more and more of these. So I think that's a really interesting thing that's happening in the .NET ecosystem. Okay, so that was my condensed highlight of what's new in .NET 9, and I wanted to come back to just an announcement about my book. If you have not been able to get your hands on the 5 pillars leadership for effective custom software, then you can get it on audiobook or Kindle or hardcover or softcover, and of course you can request a free electronic copy of the book. I think we have 3 minutes for questions in the Q&A window. If anybody has follow-on questions for any um, content. All right, so let's see if we have any questions here. .NET Aspire for Cesar. .NET Aspire supports integration with continuous integration and continuous delivery pipelines. That's a question. So, um, because everything published from a .NET Aspire app is a series of containers, then right now you would use just what you normally use to package and archive and deploy containers. And so whether it's Azure Pipelines or Octopus Deploy or GitHub Actions, it's just containers. Now, the next version of Aspire, they are working on making this automation built in so that things that we've done since containers came out, we don't have to do anymore. That's the on the roadmap for the next version of Aspire. But because the architecture is Linux container based, then your DevOps automation, you're just managing containers. So .NET Aspire um, will automate CI/CD, but right now, because it's container based, it fully supports your existing CI/CD methods for containers. All right. Another question. How can I request a free electronic copy of your book? Um, Chloe put in the link right there. And if you are listening to a recording of this after the fact, you can go on our website or you can just send me an email and that'd be perfectly fine as well. All right. And I think there's these other questions we answered in line. Yep. Okay. Awesome. Well, thank you so much for being such an engaged audience. I appreciate the questions that did come through in line. I was able to work those in. And great to get into 2025 with what's new in .NET. And I hope everybody had a great new year. And remember, if you are the lead architect or lead engineer of a software engineering team, I invite you to come to our architect forum that happens on a monthly basis that I facilitate. And if you would like your boss or VP of development or whatever executive oversees your software, if you would like them to come, then just send them the link to our executive leadership forums and let them know that they're invited. And thank you very much. And make sure to check your email for our next training session that will be published very soon. So thank you all and have a great day. God bless.